So in the previous video of mine, you have understood or I have explained to you the laws of exponents for rational numbers or real numbers. And now it was a revision of what we have learned in our lower grades. Now let us see the application of these laws of exponents which were applicable on real numbers. We now try to apply them on others irrational numbers also. So let us try to solve them. Okay. Before that, before we plunge into that, I think I have to remind you of another. It is not another law or whatsoever. It's just to brush what you have learned. Okay, just let's go. Let me tell you that. Now I'm having a to the power minus n. If I'm given a to the power minus n, what does this mean? This means this minus or in the index, it means it goes to the denominator, 1 to the power a to the power n. This is it. And if I have to write a to the power 1 by a to the power n in the numerator, I will write a to the power minus n. So a to the power minus n is nothing but 1 by a to the power n. That when you have this minus, it basically indicates that it is the number is in the denominator. So always the numerator will be 1 and this will jump onto the new denominator. So this is what you have to remember. Okay, this has to be remembered. I mean, all this, in fact, everything has to be remembered, the laws of exponent, but this is also one of it which has to be remembered. Now, with these concepts in mind, let us solve exercise 1.5 of the NCERT textbook of chapter 1, which happens to be the last exercise of this particular chapter. Let us try to instead of going to examples and understanding, let's try to solve this, and in the process of solving that, I will tell you the applicability of these rules or the laws of exponents that we have learned. Okay, fine. So now exercise 1.5. First one, that is the first main of it. Find 64 1 by 2. Now I have to find out what is 64 1 by 2. So when I say 64 1 by 2, imagine 64 is a square number, it's a perfect square, right? Perfect square of which number? You remember 1 into 1 square is 1, 2 square is 4, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, okay? 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, and 10 square is 100. I will go to the squares of other numbers later on, but right now you try to recollect these 10 square numbers. So the moment I see 64, in this it is always a perfect square. And of which number is it perfect square of? It's a perfect square of 8. You can see here it's a perfect square of 8. So I will write 64 as, instead of writing 64, I will write 8 square. So 64 1 by 2, 64 will be replaced by 8 square. So this I will write it as 8 square 1 by 2. As per the law of, which is that law? Which is, you have a to the power m whole to the power n is equal to a to the power mn, right? That is what you have learned. So here it is going to be 8 square into 1 by 2. 8 square into 1 by 2. So this will be 8 to the power 2 into 1 by 2. This 2 and this 2 get cancelled. So you are left with 8 to the power 1. That is nothing but 8. So the answer is 8. Similarly, let's see the second one. Second one says 32 to the power 1 by 5. 32 to the power 1 by 5. 32 is not a perfect square, because if you just see a table here, you don't find anywhere 32. You have after 25 you have 36. 32 lies between 25 and 36, that is 5 square and 6 square, so it is not a part of anything. So how do you find out? Okay, you have 32 to the power 1 by 5. Now let us see how 32 is not a perfect square. I have to write, get a square, I should write represent 32 in such a way that it has, I get 5, so I have to cancel this 5. Okay, so I'll go by the LCM method to find out which number I can do. 32 is 2 1s are 2, 6 are 12, again 2 8s are 16, okay, 2 4s are 8, then again 2 2s are, so 1 2 3 4 5, so I'm having 5, so I can write 2 2s are 4, 2s are 8, 2s are 16, 2s are 32. So 32 I can write it as 2 to the power 5. So this I will write this as 2 to the power 5 whole to the power 1 by 5. So this is equal to 2 to the power, same rule, this same rule applies, 2 to the power 5 into 1 by 5. 5 get cancelled, so you are left with 2. So the answer is 2. Okay. Because 32 is not a perfect square, we try to find out how do I need to get 5, okay, if it's possible. So I try to represent 32 in a form such a way that this 5 gets cancelled. So I just try to find out the factors of 32 by using the LCM method. When you find out the factorizing method, right? This is called factorizing method. So I try to factorize it, and once I factorize it, I got 1 2 3 4 5. So 32 could be represented in the form 2 by 5 and 32 and 5. So this 5 gets cancelled. So you are left with answer 2. Okay. So the next third sum is 125 to the power 1 by 3. Now if you just see this, I have written here up to 10. Now let us go further. 11 square is 121. 12 square is 144. Okay. Then 13 square is 169. 14 square is 196. 15 square is 225. So this is, again, you have to remember this. You remember this. Now you have been given 125. 125 is not any perfect square because 121 and 144, it lies between this, so it is not a perfect square. 11 square is 121, 12 square is 144. This 125 lies between these two numbers, hence it is not a perfect square. So again we go by the factorization method to find out if I can do something to represent 125. So I will take 125, divide 5, okay, 5 2s are 10, 2 remainder, 5 5s are 25. Then again I divide it by 5, 5 1s are 5 5s are 25. So again if I take this, 5 1s are 1. So I got 1 other, it is not to be considered. Since the remainder is 1, it can be, but it's not relevant. So I can write 125 as 125, I can write 5 into 5 into 5, right? So this is equal to 5 to the power 3. So 125 can be written as 5 to the power 3. So I will write the same thing here. This way I write 125 as 5 to the power 3 whole to the power 1 by 3. So this will be 5 to the power, again using the same rule, 5 to the power 3 into 1 by 3. 3 gets cancelled, so you're left with 5. Okay. With that, we have completed the first main of exercise 1.5. Now let us see the second main of exercise 1.5. Right now, if you want to see it's okay, or if you want me to see it in the next classes, we will surely see in the next classes. If you, as you find it's okay. Okay. So maybe we'll see it in the next class, so that you will be able to grasp. So remember all the laws of exponents which I have told you. It's very important to remember them. Okay. See you then. Take care. Bye. God bless you.